Angles. So far, we have covered the first 7 of 23 definitions in Book 1 of Euclid's Elements, which lay the foundation for plane geometry, number theory, and solid geometry. This unit will cover definitions 8 through 12, which apply to angles. Below is a summary of the 8 definitions that will be covered. Numbers 8 and 9 introduce and define angles. Number 10 introduces and defines perpendicular lines and right angles. 11 and 12 define obtuse and acute angles respectively. Let's dive deeper into each one. Let's start with the definition of a plane angle. It is the inclination to one another of 2 lines in a plane which meet one another and do not lie in a straight line. In modern vocabulary, that means an angle is formed when 2 rays, segments, and/or lines intersect at a point. Our angle has 2 sides, ray BA and ray BC, and it has a vertex, point B. The angle, which is a geometric figure, is represented by angle ABC, using the 3 points that the angle follows. And when the lines containing the angle are straight, the angle is called rectilinear, which is definition number 9 in Euclid's Elements. When angles are used in mathematics and other applications, people are using rectilinear angles. All the angles in this unit are rectilinear, and examples of them are shown below as pictures. In addition to this angle being named angle ABC, as described a little bit earlier, it can be named in reverse order too, angle CBA. It could also be named as angle B since there is only one angle occurring at the vertex. You can also have a Greek letter inside of it, for example theta. And finally, any number or symbol. It may be a Greek letter, but it doesn't always have to be. And it's placed inside. We could have also named this angle angle 1 or angle 4 or the Greek letter alpha and so on. There is a distinction between a geometric figure and its measure. Angle ABC and angle RST are geometric figures. Now, when we have this little m in front of the angles, it's read as measure. So the measure of angle ABC and the measure of angle RST, they are numbers. The measure of angle ABC is 32 degrees. Written out in notation, we put the lowercase m in front of the angle symbol, and then the name of the angle, and then equals the degrees that it measures. And again, it's read as the measure of angle ABC is equal to 32 degrees. Using the vertex to name an angle doesn't always work. The vertex cannot be used to name an angle uniquely when there is more than one angle with B as its vertex. There are 3 angles in this diagram to the right with the same vertex. We have angle DBC, we have angle DBA, and we have angle ABC. Since there's more than one angle at the point B, we cannot simply say angle B. We have to be specific and use 3 letters when more than one angle exists at a vertex. The angles for this figure can also be named as angle ABD, angle CBA, and angle CBD. We could use angle theta, angle alpha, and we can use theta plus alpha for angle CBD. But as stated before, angle B cannot be used as there are multiple angles, 3 of them, that share that same vertex. Now let's discuss definition 10, right angle and perpendicular. When a straight line standing on a straight line makes the adjacent angles equal to one another, each of the equal angles is a right angle, and the straight line standing on the other is called a perpendicular to that on which it stands. So line AB stands on line DC so that it forms 2 equal angles, each measuring x degrees. Segment AB is perpendicular to segment BD, and segment AB is perpendicular to segment BC. Since the 2 angles are congruent, next to each other and form a straight line, they both have to be right angles. A right angle is an angle with a measure of 90 degrees. So the measure of angle ABC is equal to the measure of angle ABD, which is equal to 90 degrees. There is a special symbol for a right angle. A squared corner at a vertex is used to indicate that there is a right angle which makes the segments, rays, and/or lines perpendicular to one another. The corner is shown in red to make it easy to recognize a right angle. So angle ABC is a right angle, and the measure of angle ABC is 90 degrees. An obtuse angle is an angle greater than a right angle. In modern terms, an obtuse angle is an angle with a measure greater than 90 degrees and less than 180 degrees. So we have an obtuse angle, angle ABC, and the measure of angle ABC is 135 degrees. An acute angle is an angle less than a right angle. In modern terms, an acute angle is an angle with a measure greater than 0 and less than 90 degrees. So here we have in our diagram angle ABC is an acute angle because the measure of angle ABC is 45 degrees. In Euclid's The Elements, there is no mention of a straight angle. The measures of angles are only between 0 degrees and 180 degrees. In modern geometry, the idea of a straight angle is standard. Below is a figure of a straight angle, angle ABC. This leads us to the definition of a straight angle. Angle ABC is a straight angle if and only if point B is between A and C, and the measure of a straight angle is 180 degrees. So if angle ABC is a straight angle, the following statements are true. Points A, B, and C are collinear. The sides of the angle, ray BA and ray BC, are opposite rays. The vertex of the angle is point B, and all straight angles are congruent, since their measures are always the same, 180 degrees. Another modern definition that was not used in the Elements is that of a reflex angle. A reflex angle is an angle with a measure that is greater than 180 degrees. So the measure of this reflex angle from CBA, the reflex angle's measure is 235 degrees. So here are all of the classifications of angles. We have an acute angle when its measure is between 0 degrees and 90 degrees. We have a right angle when the measure is 90 degrees. An obtuse angle when the measure is between 90 and 180 degrees. A straight angle is an angle whose measure is exactly 180 degrees. And a reflex angle is an angle whose measure is greater than 180 degrees. Any angle with a measure between 0 degrees and 180 degrees has an interior and an exterior, as shown in this diagram. The interior section is inside of the angle, and the exterior section is outside of the angle. Intersecting lines form angles. When an angle is formed by either two rays or segments with a shared vertex, one angle is formed, and it's shown as theta in this diagram to the left. It's also angle ABC. When two lines intersect, four angles are formed, and these angles are numbered in the diagram to the right.